Number 4. The curve C has equation y is equal to f of x, where x is a real number. Given that the differential of f of x is 2x plus a half cosine x, the curve has a stationary point with x coordinate alpha, and alpha is small. Part A, use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. So because the question has said that alpha is small and that we need to use the small angle approximation, we will look for the small angle approximation, which is given in the formula booklet, and the one that we will be using is the one for cosine theta. The other piece of information that's been given is that the curve has a stationary point with x coordinate alpha, which means that the differential of x at this point would be equal to 0. So for part A, if we substitute all the x's with alpha, that means we would have 2 alpha plus a half cosine alpha, and at this point we would have a stationary point, meaning that this differential would be equal to 0. We can then replace our cosine alpha with the small angle approximation, so we can write this as 2 alpha plus a half bracket 1 minus alpha squared over 2 is equal to 0. If we then expand this bracket, we can rewrite this as 2 alpha plus a half minus alpha squared over 4 is equal to 0. And as we can see, this is a quadratic equation. So we can rewrite it in a proper quadratic form by putting minus 1 over 4 alpha squared. We then have plus 2 alpha plus a half is equal to 0. We can then solve this in our quadratic solver in the calculator by going to menu and then going down to equation. We are then going to select 2 for polynomial, and we're going to select 2 for a quadratic equation. Our A value is minus a quarter, the B value is 2, and the C value is a half. And if we press equal, we will get the first value of alpha, which is equal to 8.243. And if we press equal another time, we will get the second value of alpha, which is minus 0.243. And because the question says that alpha is small, the value that we will be going for is not this one, but this one, which is alpha is equal to minus 0.243. The next part says the point P, coordinate 0,3, lies on C. Part B, find the equation of the tangent of the curve at P, giving your answer in the form y is equal to mx plus c, where m and c are constants to be found. So for part B, we know that the gradient is given by the differential of the equation, and we know that this differential is 2x plus a half cosine x. Therefore, at point 0,3, when our x coordinate is 3, to find our gradient m at this point, we can just substitute 3 for all x values. So we can write this as 2 bracket 0 plus a half cosine 0. And if we work this out, this just gives us a half. From the coordinate, we can see that 3 is also the y-intercept. So in order to write this equation, we can just write it as y is equal to a half x plus 3.